So, this next chapter is all about graphing, things along those lines. First one, using graphs to relate two quantities. What's day about? It's about looking at graphs and interpreting what they tell you, looking at data and what it tells you. Okay, relating things coming and going, being able to understand what a graph tells you. So the graph shows the volume of air in a balloon as you blow it up. What are the two variables? My two variables are V. I would use V for volume. And then T for time. Okay? So that's what you want to have. It's not always X and Y. Your variables are other things. And you can have equations sometimes that do the graphs, but not always. Sometimes it's just a graph of you collect data. Don't always have equations that give them to you. But you still have to interpret them. That is part of math. Okay? Now, it says, describe how the variables are related at various points on the graph. So you're blowing up the balloon. Okay? So as we go along, we have this first part here. At 0, no time has happened, and the balloon is uninflated. What happens? You blow it up, right? So during this part right here, what's going on? You're blowing up the balloon. The balloon is expanding. Yeah, balloon expands. And then you take a breath. And if you're smart, the balloon does not get any smaller, because when you go to take a breath, you pinch the end of the balloon off. It would really suck to blow on it and then let all the air back out. To blow on it and then let all the air back out. People do that before. They don't know how to blow up a balloon. But that's what's going on here. So you can imagine that's what's happening. You blow on it, you take a breath. You blow on it, you take a breath. You blow on it, you take a breath. You blow on it, and then from there, what happens at the end? It pops, because it's instantaneously gone. So at this point here, it pops. Okay. And that makes sense, right? And it wouldn't be that it let it, because then it'd be slowly deflating. Popping would be instantaneously flat. So that makes sense where it drops off like that. Okay? So here's what I want you to do. You've got two graphs at the bottom. Okay? So you've got two graphs at the bottom. I want you to do the same thing I just did. First, identify two variables. Second, describe what's going on. First one, you've got a board length, and the second one, you've got how much cell phone costs. So do the same thing I just did. First, identify two variables, one for each thing. That should be easy enough to do. Second, try to use the graph to describe what's going on. Like I did with blowing up the balloon. It inflates, you take a breath. You inflate it, you take a breath. You inflate it, you take a breath, and then it pops. Try to describe what's going on with these two graphs. Okay? Let's take a look at these. So the first one, I would use L for length. And then, of course, T for time. And what's happening to the board over time? What's going on with this thing? It's going down. It's a certain length, and then all of a sudden it's shorter, then all of a sudden it's shorter, then all of a sudden it's that long there. So what's probably happening? Yeah, it's getting cut. You're cutting off the board. You're sawing it, so it's long, and here you cut it, and here you cut it again, and here you cut it again. And it makes sense. It's so long, you cut a piece off, it's shorter, it's shorter, it's shorter. I keep cutting it, it's still too short. Okay. Second one. C for cost. And then I would use M for minutes. Because that's what's given to me. Usually use T for time, no matter what. Whenever it's time, you just use time. But they give me minutes. I'm going to use M for minutes. It doesn't really matter. Okay. And then it looks like for here, you got a steady cost. And then all of a sudden it starts going up. So either, and it's number of minutes to call. So probably what's going on here is you have a flat rate. You can make, it's one charge. You get to make free calls up until you have a certain amount of time, and then it starts going up. So that's where like the free time, this is free minutes. It doesn't cost you anything more than your basic plan. You get so many minutes, and then after you hit those minutes, you have to start paying. So it starts going up in price, something along those lines. It's not an uncommon thing with phones. Any questions? Okay. All right. So, problem number 2, matching the table in this graph. So Band allowed fans to download its new video from its website. The table shows the number of downloads after 1, 2, 3, and 4 days. Which graph could represent the data in the table? Well, a couple of clues. First of all, these numbers are all getting larger. So it's not going to be D. Because those numbers are all going down. It's not like they're saying, "Oh, we don't want it. Take it back. Take it back. God, this song sucks. Take it off my computer. You get it back." That's not what they're doing. They're downloading it. They obviously like it because you're doing more and more. So we have to look at the other ones and compare them. They're all going up. For A, they're going up steadily. Each day they're increasing by the same amount. For C, they start going up fast, then they start slowing down. For D, they go up. They start out slow, and then it starts going up. Look at the data. Does it go up by the same amount each time? No. So if it doesn't go up the same amount each time, it's not going to be A. So I look at C and I look at D. Is it going up by more or less? Okay, thank you very much. Okay. So I look at the numbers here. I go from 300, around 350 to a little more than 1,000. That's a jump of like 700, almost 700. Then I go up another 3,000 more than that. And then I go up by like 7,000 more than that. So what's happening? It's going up faster each time. So it would be B, because it's getting steeper. Each jump is a larger amount, so it's actually getting steeper and how fast it's going up. Okay. Okay, last one. Sketch a graph. The model rocket rises quickly, then slows to a stop as fuel burns out. It begins to fall quickly until the chute opens, after which it falls slowly to the ground. So here's what you're going to do. Okay. Gentlemen. Focus, please. So here's what you're going to do. You're going to have a graph. Height. I know I ran out of room. And time. Where's the rocket going to start at? Where's your graph going to start? On the ground at time 0 at height 0. And sketch a graph that goes with this. What do you think would fit these things? Rocket rises quickly, slows to a stop, starts falling quickly, and then slows down when the parachute comes out. What's a graph like that going to look like? Sketch a graph. What do you think it's going to look like? Realistically, there is no really wrong answer on this one. As long as it somewhat resembles something like this. Starts out fast and then kind of slows to a stop and then starts to come down, and then at some point the parachute comes out and it descends at a slower rate, something along those lines. Yeah, that's about what it would look like. This would be where the parachute comes out, would be there. Okay. If it looks anything like this at all, if this was a test question, and you gave me anything that looks somewhat like this, I would be extremely lenient. But having done this type of problem several times before and actually having shot off rockets several times before, this is about what their flight actually looks like if you were to plot it out. Okay, so as long as you're close to this, you'd be good.